Okay, so this is the first method in the category of open methods. So the name of the method is called fixed point iteration. Now, suppose we are given a function f of x and we want to find out the root of this function. That means we want to find out the solution of f of x is equal to 0. Now, from this f of x is equal to 0 expression, in this fixed point iteration method, we will find out an expression such that it will be given as x is equal to c of x. So from this function f of x is equal to 0, we will make an expression in such a way that it should show that x is equal to 0 of x. Now we can find so many expressions in this form from this function. So there must be some constraint on this g of x that we will discuss in this video, that uh, what is the constraint on this g of x. So this is the basis of this fixed point iteration. That means we will say that the x value at the latest iteration will be equal to the g function value at the old value of x. So this is the iterative formula. Now this type of methods, or this method is only applicable to monotonically increasing or decreasing functions. So that means either the function should be like this or the function should be like this. So either the function should monotonically decrease with x or the function should monotonically increase with x. So for this kind of functions, we can use fixed point iteration method to find the root of this function. Now let us understand this graphically. So suppose this is my function, uh, or let me make it again. So graphically we want to understand this. So this is my y equal to x line, and this is my function g of x. So what we are doing here is that, so so what we are doing here is that, suppose this is my x naught. So this is my x naught, this is my x naught first guess. So what we are doing is that at x naught we are trying to calculate the function g of x. This is my g of x naught. Then the next guess will be equal to this. So this is my latest guess. Now at x1, so what we are going from here to here, then here to here. Then we are calculating the function value at g of x1. This is my function value at g of x1. Then the next value of this latest iteration will be this x2. And then for the next iteration we will calculate the function value g of x2, and then we will calculate x3 in such a way that my root is here. this is my xr, my true root. So by this is how we are basically approaching the final solution, because when x is equal to g of x, that is this particular point, when x is equal to g of x, that that is where the solution exists for f of x is equal to 0. So essentially, if we are trying to find out the f of x is equal to 0, so that means we are trying to find out the value at which x is equal to gx. That is my point here. This is that point, and how we are approaching that point in this fixed point iteration method is, if we graphically understand this. So this is my initial guess. Then we are calculating the g function value at x naught, and that will be equal to the next the latest value of x1 at the first iteration. Similarly, we will calculate the g of x1, and that will be equal to the x2, and this is how we are approaching the true root. So that is the graphical representation of this basically fixed point iteration method. That's what we are doing. Now if we write down the recursive formula, that then the recursive formula was that xk plus 1 was equal to g of xk. So that means the x1 is nothing but g of x0, x2 is nothing but g of x1, x3 is nothing but g of x2, and so on and so forth, and we will go xk plus 1 is equal to g of xk. So that's what the recursive formula says. Now let us try to understand that what is the constraint over function g of x so that the convergence is achieved. Okay, so let us say that how we are going to approach this. So suppose f of x is 2x minus 3 is equal to 0. Then out of this we can say that, you know, so if I want to make an expression out of this, then I can say that x is equal to 3 of x minus 3. Then x becomes so this can be one expression, or the second expression can be x plus 3 divided by 3. This can be the second expression out of this, or directly we can say x is equal to 3 by 2, that is true root. So there can be multiple expressions out of this function. So either this can be g of x or this can be g of x. Then what is the constraint on this g of x, that this basically this approach fixed point iteration converges, and that we will understand by error analysis. So in the next slide we are going to do that. So this is my error analysis. So let us understand this with the help of this error analysis thing. So we have xk plus 1 is equal to g of xk. This is my first equation. Now if suppose x r is my true root, that means the x r will be nothing but g of xr. This is my second expression. So if I subtract second minus first, then it says that xr minus xk plus 1 is nothing but g of xr minus g of xk. This is my expression third. So from this part we will, note down this expression third, that is xr minus xk plus 1 is g of xr minus g of xk. This is my third expression. Now there is something called divergence theorem. This divergence or divergence mean value theorem. This theorem says that if a function g of x and its first derivative are continuous over an interval AB, then there exists at least one value of x is equal to j within the interval such that g prime j, or you can call it chi, is equal to z of b minus z of a divided by b minus a. Now if we take a is equal to x I or xk and b equal to x r, suppose if we do that, or let us say let's follow the same convention, a equal to xk and b is equal to xr. So from the previous expression what will happen, g prime chi will become g of xr minus g of xk upon xr minus xk. This is my expression, or from this let us write down that g of xr minus g of xk equal to g prime chi xr minus xk. Let us say this is my expression 4. So let us say this is my expression 4. So from the expression 3 was that xr minus xk plus 1 equal to g of xr minus g of xk. This was my third expression, and the fourth expression was that xr minus xk plus 1, sorry, so the fourth expression was g of xr minus g of xk equal to nothing but xr minus xk g prime chi. This was my fourth expression. Now if we compare these two expressions, then we get xr minus xk plus 1 is nothing but xr minus xk g prime chi. Now if we define error as xr minus x, then e at k plus 1 is nothing but e at k g prime chi. So that means that e at k plus 1 and e at k is equal to g prime chi. So now if my solution is converging, that means if my solution is converging, then mod of ek plus 1 upon mod of ek must be less than 1. This implies that mod of g prime chi must be less than 1. So this is the constraint over function g of x. So if this condition is satisfied, then my solution will definitely converge towards the true root in this fixed point iteration method. In the next video, we will take one example and then try to show you that what is happening in the algorithm numerically. So we will try to understand that thing. See you in the next video.